another way to look at the same situation. Just kind of strip the graph down to some bare bones. We've got an original y here, which is equal to y naught. This will be our point x naught, y naught. Okay, and we can, if we wish, go ahead and project down here. Say, here's our point x naught. Okay, and so here's our tangent line. Now we don't know what the graph is actually doing, but we can see very clearly what the tangent line is doing. What the tangent line is doing doesn't depend on what the graph does as you move away from this point. It only depends on the way the graph looks in the very immediate neighborhood of this point. Okay, well, so what we have is between this point and this point of our tangent line, we have some change in y, which is simply the vertical displacement from this point up to this level. And we've projected the new value of y over here, so here's our new y value. Here's our original y value, this being again the point x naught, y naught. And we can then see that the new y is equal to the old y, the y naught, which is this, added to the delta y. And we can write y equals y naught plus delta y. Now, that should be fairly obvious, I hope. And if it is, then we can go one step further and say that, well, okay, what's delta y? Well, it's y naught plus, let's see, here's our delta y. Let's see, we've got a delta x down here, right? So that's y naught plus, let's see, delta y over delta x is equal to the slope, so that the slope multiplied by delta x has to equal delta y, doesn't it? Okay, so this is slope times delta x. And I'll just kind of jot down over here that slope equals rise over run, of course, and that's delta y over delta x, so delta y equals slope times delta x. So we've got to understand this very well to understand why y then is going to equal y naught plus the slope times delta x. Now let's see. If the coordinates of this new point are x, y, then okay, this point then is x. Then y equals the slope times delta x. Let's see. Well, delta x is then x minus x naught, isn't it? So it's slope times x minus x naught. Okay? And of course then the slope, if we have a function f of x, the slope of our tangent line, assuming this is our tangent line, is y naught plus slope, which is f prime at the point of tangency, which occurs at x naught, multiplied by x minus x naught. This is just another instance of this. So that anything we can now do with a straight line, we can do with this tangent line, predict its value at any point. And more particularly, we can consider the difference between the value of y on the tangent line for given value of x and the value of y at our actual function of x, which is probably not going to be a straight line function. We wouldn't generally bother finding a tangent line to a function that already has a straight line, because the tangent line will be the same as the function. Okay? So if the function has some kind of curvature, then maybe it curves down below the tangent line, maybe it curves above the tangent line. If you go far enough out along the tangent line, it might curve up and come back and go back up and all kinds of stuff. But close to the tangent line, we expect some kind of curvature of the function away from the tangent line. If the function doesn't curve too far away, then rather than evaluating the function at a given point, we might just evaluate the tangent line and say that, okay, well, that's not exactly equal to the value of the function, but it's close enough. And of course we have to determine what we mean by close enough and how we determine what, just how close the thing is. But we say the value in the tangent line is close enough for what we're trying to do to the actual value of the function. And it's much easier to figure out the tangent line. We just use this sort of thing, okay? Much easier to find out y values on a straight line. That's a very easy thing to evaluate, and it might be much easier than trying to evaluate our function. Okay? Now, it's always easy to evaluate a function if it's something you can plug into a calculator, but you can't really think about the output of a calculator. You can't think about where it comes from. You can easily think about this and about the way values change and understand the deviation of the function from the tangent line and just where it deviates so much that you can't use this approximation anymore.